So exponent rules, the thing you need to remember about exponent rules is this deals with variables and numbers and their exponents when you're multiplying and dividing. So this deals with variables and numbers that have exponents with them. That's why it's called exponent rules. And their exponents when multiplying and dividing them. So if you're adding or subtracting numbers or variables with exponents, you actually will be combining like terms. So make sure you know the difference. So this will only work when you're multiplying and dividing. All right. So just a reminder, you have two parts to a problem whenever you're working on these types of problems. So you have the number that's kind of to the bottom left, which is a little bit bigger, and then you have the number that's in the top right corner of it, okay? This number right here is called your base, and then this number that's in the kind of the upper right corner is your exponent. And so make sure that when you're writing your numbers and answers to problems that you keep them separate. So remember, the exponent should be smaller overall compared to the base. All right. So if you are drawing your own notes, you'll need to, at this point, make your own little column down the middle of your paper. And then on the left-hand side, we're going to put the algebra and a description of the rule. And then on the right-hand side of your paper, we will be putting examples that go with each of the rules, okay? Now, this is something that you would have done in Math 1. So this is something that might be familiar to you as we start going through it, but if not, then you will have notes that deal with it, okay? So the first exponent rule that you need to know, and you always know that my lid breaks, so here we go. The first exponent rule you need to know is what's called anything that has a zero power with it. So if you have a number or a variable, so I'm just going to use the letter A, and it has an exponent with a zero in it. This rule is super simple. Anything that has an exponent of a zero will actually always equal 1. Doesn't matter how messy it is, it will always equal the number 1. Okay, so just a little description. You could put anything to the zero power equals 1. All right, so let's do a couple examples with that. So what if we had something like this? Okay, well, notice that will equal 1 because you've got x squared times y. Notice you're multiplying them. And all of that is in parentheses, and it's to the zero power. Well, anything to the zero power, and since all of that is technically to the zero power, power is another name for exponent, it will equal 1. So, what if you had something like this? And we have to figure out what that is equal to. If you look, the 2, even though you can't really see the exponent with it, it technically does have an exponent. Anything that you don't have an exponent with is actually to the power of 1. So that 2 has a power of 1. The x, it doesn't have an exponent with it, so it's technically to the power of 1. And then the y has a power of 0. So that's the exponent. Anything that's to the first power is just whatever that number is. So 2 to the first would be 2. X to the first would be x. So they all just kind of come over. But y to the 0, remember, anything to the 0 power is 1. So y to the 0 would actually end up being just the number 1. So then you have 2x times 1. Well, anything times 1 would just be whatever it is. So you end up with 2x as your answer. Okay, so that's the first exponent rule. The next exponent rule that you've got to learn is what to do when you're multiplying like bases. Okay, so I'll use the same letter as I did before. Let's say that you have the base that's an A, and then it has the exponent or power of m. And you're multiplying that times base A with an exponent or a power of n. So notice what I mean by this is you're multiplying. So notice you're multiplying like bases. So remember what we talked about earlier. The base is the number that has the exponent with it. So like in this little part right here, A would be your base and m would be your exponent, or like I've been saying, power. Here, A would be your base and n would be your exponent. And so notice the bases are the same. So that's what I mean by like bases, and you're multiplying them. So the rule there would be when you're multiplying like bases, you actually add the exponents. So multiplying like bases, then you add the exponents. So make sure you remember it's the exponents that you have to add. Okay, so when we do that, the base stays exactly the way it is. So notice I just bring my A over, and then whatever these numbers are, because usually they will be numbers, you just simply add them. So you take the m plus whatever the n is, and you would simplify that, and that would be your answer. So some examples with that. Let's say that you've got x squared times x to the 4th. Okay, and you have to figure out what that equals. And usually with these problems, they'll say something about simplify this expression. And so to simplify it, look at the bases, look at what's going on here. The bases are both x, so that means that they have like bases. And so since you're multiplying them, you simply add their exponents. So remember the base stays the way it is. And then you take their exponents, the 2 plus the 4. And then after you do that, it'd be, well, 2 plus 4 is 6. So it'd be x to the 6th. Okay, so let's do another one. Say we have 2a to the 2nd power times 4a to the 6th power. And we have to figure out what that equals. Well, we've got a couple things going on here. First of all, these numbers are not actually attached to the exponents. The reason for that is kind of what I was talking about up here. These were 3 separate things, kind of. So it's the same thing here. This is 2 times a to the 2nd. So this is kind of like 2 separate things. You've got the 2, and it's got its own power, because remember, like I said up here, if there's not a power or an exponent with it, then remember I told you it would have an exponent of 1. So you always want to put those, I call them hidden exponents, because you can't, they're not going to be drawn for you, so you have to put them in there. And so if it's kind of a number or variable that doesn't have an exponent with it, then that technically means the exponent is going to be 1. So it'd be 2 to the 1st, and then the a has the 2nd power with it. And then you have 4, notice it doesn't have an exponent with it, so you put the 1 as the exponent. So it'd be 4 to the 1st, and then a to the 6th. Okay, so then from there, we are multiplying everything because there's no addition or subtraction between them, and there's not a division bar. And so when you multiply, With the numbers, if they don't have an exponent with them, then you just treat them like you always do numbers. So like the 2 to the first is technically 2, the 4 to the first is 4, and then you just multiply the numbers. So it'd be 2 times 4, which is 8. And then now you've got a base, a variable with an exponent, and then the same base, the same variable, and an exponent that's with that, and you're multiplying them. So remember, like what we did with the x just a second ago, you keep the base the way it is, and then you, because you're multiplying, you add the exponents. So 2 plus 6 would be 8. So altogether we get 8a to the 8th power. All right, so let's do one more and then we'll move to the next exponent rule. So let's say we have negative 3 y to the second times negative 4 x y to the negative second power. All right, notice everything's being multiplied again, but we also have those pesky little hidden exponents, okay? So with those, if you want to put them, you can put them in there. But for this problem, you'll notice that it won't really make a difference when we do, okay? Because there's not going to be like bases with the hidden exponents. But if you wanted to put them in there, you can. So just like what we did up here, the negative 3 and the negative 4, everything's being multiplied. So you multiply the numbers like normal. So you've got negative 3 times negative 4. A negative times a negative makes a positive. And then 3 times 4 would be 12. And then notice we have an x here, and there's nothing else that is a like base with it. And so if there's nothing else that's a like base with it, that means you just have to bring that over. And so I'm going to go ahead and bring my x over because there's nothing else that will be multiplied with it. And then from there, we have y to the second. And then that has a like base with this one right here. So it's times y to the negative 2. So remember, since you're multiplying, you add the exponents. So technically, it would be 2 plus negative 2. Well, 2 plus negative 2 actually ends up being 0. So we're going to erase this and we're going to write 0. But if we kind of remember the exponent rule from before, when we have something to the 0 power, it actually ends up being 1. So you got to remember the 12 and the x has its own exponent. They're technically to the power of 1. So 12 to the first comes over as 12. X to the first comes over as x. But then y to the 0 ends up being 1. So this would actually be times 1. And that would just leave us with 12x. So 12x would be our answer. All right, so then the next exponent rule. What do we do when we are dividing like bases? Well, if you kind of use a little bit of reasoning and what happened when we were multiplying like bases, you might be able to figure this one out. All right, so this will look like, and I'll use the same letter so that we're consistent. Let's say we have the letter A, and it's to the m power, and this time we are dividing by another A with a different power, okay? So when you are dividing like bases, so let's write our description down. When we are dividing like bases, well, what do we do? Well, when we were multiplying like bases, we added. So kind of reasoning through that, when we're dividing like bases, we would actually subtract the exponents. Okay, so let's kind of talk through some of those. Well, for this problem, we have like bases because they both have a base of A, and so we subtract. And you will find out when we do the examples, there is a little thing you have to remember when you're subtracting as to where to put your answer, but we'll talk about that when we get there. And so if I was to subtract these, we would take m minus n. And then we would have our answer. Okay, so let's do an example so you can see how it works when we actually have numbers in there. So let's say that we have x to the fourth divided by x to the third. All right, so when we have something like this, notice we have a base of an x and an exponent of 4, and then a base of an x with an exponent of 3, and then we're dividing them. So that rule does apply here because we're dividing like bases. And so when we divide like bases, we simply subtract their exponents. But this is the thing that I was kind of warning you about a second ago. When you subtract them, to end up with a positive exponent, and you'll see why I say this in a minute, but to end up with a positive exponent, you have to actually put the answer where the bigger number is. So like if you look in this problem, or where the bigger exponent is. So if you look in this problem, the exponent 4 is bigger than 3, right? So then you would put your answer on the top of the fraction. If it was kind of flip-flopped and you had the x to the fourth on the bottom, you would actually put your answer on the bottom of the fraction so that the exponent ends up being positive. Okay, so for this problem though, the exponent of 4 is bigger than the exponent of 3, so the answer will go on the top. Okay, so on the top of my fraction, which I don't technically have to put it on the bottom or put anything on the bottom because it'd technically be a 1. You put the base, you keep this base the same, and then you take the 4 minus the 3, the bigger number minus the smaller number. And so when you do that, 4 minus 3 is 1. So it'd be x to the first power. And remember, we don't typically put the 1 when it's an exponent of 1, so it'd technically just be x. Okay, let's do a different one so you can see kind of how different problems work with this. Let's say that we have 2x over x to the third. Okay, well, we have a number this time with this problem. So with numbers, remember, you kind of treat them just like you always treat numbers. And so this is a fraction, and technically we have a 2 divided by, well, there's not a number on the bottom, but technically that would mean that there's a 1 right there. So 2 over 1 would be 2. So we could go ahead and bring our 2 over. And then we have to deal with this part. So if you kind of think back to this problem, when we're dividing like bases, we have to subtract the exponents. So when we subtract the exponents, we would take 1 minus the other one. This has a hidden exponent. Remember, if it doesn't have 1, you write it as a 1. And we're going to subtract them. So think back to the last problem. I talked about your answer actually goes where the bigger exponent is, if you're wanting the exponents to be positive. So when I do this one, notice the 3 is bigger than 1. So I actually have to put my answer on the bottom. So on the bottom, I put x, and then I have to take the bigger number minus the smaller number. Okay, and remember that stays as an exponent. And so when I simplify this, 2 still on top, and then it'd be x to the 3 minus 1 would be 2. And then that's as far as I would go, because with your answers, you want to usually end up with a positive exponent after you simplify. Okay, so let's do one more here, and then we'll move to our next exponent rule. So let's say that we have 16 x to the second, y to the sixth, divided by 4 x to the fourth, y to the third. Okay. Zoom in just a little bit so you guys can see that a little bit better. Okay, so from here, just like the last problem, you treat the numbers like normal. Okay, even if they had an exponent, you could simplify the exponent with them and then treat them like normal. So notice you have a 16 over 4. So 16 divided by 4 is 4. And the answer goes where the bigger number is, kind of like with the exponent stuff. So that's that part. And then notice we have kind of 2 things going on here. We have the bases that have an x with them, And then we have the base of y. Okay, so you deal with them separately. So we have an x to the second divided by x to the fourth. So when we do this, remember when you divide, you subtract the exponents and you put your answer where the bigger exponent is. So the bigger exponent's on the bottom, so my answer goes on the bottom. So on the bottom, it would be x to the, well, bigger number minus smaller number. 4 minus 2 would be 2. So on the bottom, we'd have x to the second. And then when I look at my y's, it's y to the sixth divided by y to the third. Well, this one has the bigger exponent on the top. So when I do that, my answer would actually be on the top for that one. So it'd be y to the 6 minus 3 is 3. And then, is there anything else that needs to be simplified? Well, you got 4y to the third, x to the second. There's no more numbers to simplify. There's no more like bases that need to be simplified. So then that is as far as you go.